Is my voice is audible to you? Second. If my voice is audible and if everything is fine, please let me know. Right? I just want to know how many of you people are in online. Second, bros. Yeah. Okay. Okay, bros. Okay. Okay. Uh, 1 second. 1 second. Hmm. Uh, if you are in online, please say hi so that I will understand. Right? Right. So today's session is all about plate girders and it's a marathon. Today, maybe three-fourths of the plate girder will get completed. So it will be three plus hours definitely. And I can say like before I start the session, I can say like there are more and more free content is happening in an Unacademy learning app. I can recommend you guys if you are an aspirant of GATE or ESE or any other competitive examination, I can recommend you to download this Unacademy learning app because there is so many free content is also happening there. The Unacademy learning app, and you can follow me using this link. When you press this link, definitely I can say like definitely it will redirect to my page and you can follow me. When you follow me, the thing is the future coming videos of mine, already free content done of mine, you are able to access, and the PDF notes that I had already uploaded in the Unacademy app, that you are able to access for free of course. These are the benefits when you are able to follow me, brothers. Right. So before I start the session, I hope after you download the Unacademy app, select this target as GATE and ESE. And if you are a serious aspirant of GATE or ESE and or any other competitive examination, I can recommend you like to take the subscription, which is the paid course. If you want to take the paid course, you just need to use the code BT10 by pressing get subscription from Unacademy Plus. From Unacademy Plus, if you go to get subscription, you can use this code. Use the code VT10. Then definitely 10% discount on all courses in Unacademy Plus courses will directly come to you, bros. Right. Some people will also ask us, sir, first of all, please introduce yourself. I am Venkata Tilak Upalapati. Some people call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree, which is PhD. My background of education is completely into structural engineering. So here also in an academy, I am going to teach structural engineering subjects ranging from engineering mechanics, strength of materials, structure analysis, concrete structures, steel structures, and finally to construction materials and management. Totally the 6 subjects I am going to tackle in an academy. Right. So in addition to this one, some people will also ask me like, okay, sir, what is your previous work experience? Previously, I worked as research scientist or research engineer in University of South Carolina. This is in USA. And previously, I worked as head of the Department of Civil Engineering in an engineering college. This is in Andhra Pradesh in India. I have both local experience and global experience also. Being a structural engineer, even till today also, I am working as an independent structural design consultant. I personally give to my clients structural drawings to my clients and material testing reports to my clients. These are the two things generally I do as a consultant. In addition to this one, even till today, till now, I have 12 years of teaching experience till now in teaching GATE and ESE in different coaching institutes all across India. This is my brief background. Hi, Devalina. Yes, sir, Devalina. It's a 3 hour class. Yes, Devalina, it's a 3 hour class. Hope you are fine, Devalina. Right? And before I start the session, right, I just want to ask you like, you can install the Unacademy learning app. Just go to Play Store. After you go to Play Store, you type this name Unacademy learning app. When you type this name Unacademy learning app, you can install this Unacademy learning app. When you install this Unacademy learning app, this type of screen which is on the right hand side will be able to visible to you. In this one, in this main button, in this main button, you type, you in this drop down menu, you just select free classes. And after free classes, you can select the target as GATE and ESE, of course. And here in the search option, you type my name, Venkata Tilak Uppalapati. When you type this name, and if you search, press enter, then my profile page is visible too, and you are able to access all my lectures. If you are able to follow me, just say follow me. When you follow me, there are different advantages are there that I already teach you. But anyway, if you want to take a paid course, here in this main button, go to plus courses. The plus courses, use get subscription, and use the code VT10. Use code VT10 to get 10% discount, bro. Some people will also ask us, sir, if I had taken this paid course, how it is advantageous for me when compared to free users, right? Anyway, you some of the classes you are teaching in online for free na, but not all the content we are not able to deliver all the content for free of cost in this YouTube platform, or also in free classes also we may tell to some extent, not in detail. Every concept will not be covered 100% because of some time constraint and all the other stuff. And one more thing, foremost advantage, if you had taken the paid courses, instant doubt resolution. In addition to daily live classes, instant doubt resolution, the educator can directly the learner can directly talk with the educator, and the learner can resolve all his doubts by just chatting with the educator through through discussion and through polls. The educator will answer all the questions of the educator will answer all the questions of the learner or the student. That is the first and foremost advantage. And second advantage, in order to crack any sort of competitive examination, test series support should be there. The test series support we are providing in the format of live tests and quizzes. If you have taken the subscription, we are providing this test series support. You are able to write quizzes, mock tests, daily wise tests, grand tests, and all this stuff, and you can evaluate at what level you people are in terms of performance. If your performance is dropping in terms of marks or any other thing when compared to the topmost students of an academy, you can improve your performance by listening to more number of lectures in that particular area, by working out more problems in that particular topic, right? That is the second advantage. You can evaluate, that is the second advantage, how you can evaluate your performance. Third advantage is there is no need to prepare your plan. We will prepare each and every plan, and if you stick down to the plan by listening to the lectures and by attempting all the mock tests, daily wise tests, and subject wise tests every day, and we are pretty much sure you are able to crack the examination with very good rank, right? And we won't compromise in the number of hours, how many number of hours required, so that even the underperformed student can come to that level, and he or she can work out any type of problem that was given in the examination. So like that, we frame the our correct we frame the structure of the course, so that ample number of hours are there for each and every topic, right? And fourth advantage is, let us suppose, let Devalina madam is absent to a class on one day. In such case, she will be provided with the same class for n number of times in offline mode, maybe through maybe a mobile phone, maybe through a tab, or maybe through other devices maybe PC, depending on his or her comfort, definitely. So using all these four things, and definitely I can say you are for sure been very well mannered with very good rank, right? And I can say the courses that are taught by an academy in an academy platform are both in Hindi separately and also in English separately, right? For any, so depending on the requirement of the student, his comfort, he can attend either Hindi classes or English classes depending on his or her comfort, right? And I hope you can see this is in English, this is in Hindi. These are some of the topmost educators that we have directly in an academy learning app. So some people will also ask us, sir, till now in GATE and ESE, especially in civil engineering, how many courses till now you people had launched? Till now we people had launched till now 7 courses, bro. I mean, not 7 courses, 8 courses till now we people had launched in civil engineering. And out of these 8 courses, few courses are in Hindi, few courses are in English. Now some are long-term courses, some are short-term courses. If you had taken subscription, you will be given access to all the courses that are under that civil engineering that civil engineering branch. So whatever may be the future coming courses especially in that branch will be given access to you if you have taken the subscription, right? So coming to the duration of the subscription and its cost, right? For 12 months after 20th October, the price has got hiked, and after you use this code VT10, after 10% discount, the price is 27,225. This I can recommend for fourth year students. If you are a final year student, I can recommend like this 24 months course, which is 39,600 after 10% discount. This is what I can say to you, bros. And one more thing, like there is 18 months course also we had launched. This 18 months course and 24 months course I can recommend to third year and second year students, I can recommend, right? So that they will have ample time and they can crack the examination for sufficient duration, right? Yes. So and one more thing I want to convey in this Let's Crack Gate and ESC Civil YouTube channel, we had already started 3 different batches. In these 3 different, you can take use of these 3 different batches classes, which are for free of course, and you can improve your rank. And for 2021 Gate batch, this is the batch that we had started. For other competitive examinations, SSC, JE, and other things we had for state services examinations, we had launched this batch. Okay, so you can take use of this opportunity, get trained from India's topmost faculty. We as a team, we 12 people are working here in this group. Okay, right. And I just want to convey, in your previous class we completed beams, and in beams the check for web crippling and web buckling secondary effects check is remaining. So I need to teach you how to work out web buckling strength, how to work out web crippling strength. Hi Adarsh Vishwakarma. Hi bro, how are you? Hope you are fine, right? Adarsh bro, right? Okay, right. So in your previous class, as you already know, I need to teach you how to evaluate web buckling strength, how to evaluate web crippling strength. I can say, what is the safety check that I can make? Safety check that I can make in terms of web buckling is maximum shear force, Vmax, or design shear force should be less than web crippling strength. This is the first secondary safety check. And what is the second safety check that I can do for secondary effects? I can say maximum shear force developed. I can say design shear force should always be less than web buckling strength. I need to teach you. I hope you already know. Your teacher from SA or SM had already teach you how to evaluate the maximum shear force or design shear force. This maximum shear force or design shear force, or maybe maximum point load applied, anything. So now I need to teach you these two. Your SM teacher might had already teach you from strength of materials, how to find out maximum shear force and everything. Now I need to teach you how to evaluate this web crippling strength, how to evaluate this web buckling strength, right? Right now let me tell you what is web crippling strength, right? I just want to say, like, I hope if you had taken I hope you are able to see this figure, right? This is a figure. I hope you are able to see. This is a beam in front view. This is the reaction, this is the shear force reaction from, this is the bearing width, right? This is the effective bearing width, and here in this cross section of this beam, right, this is how the shear force will come on this beam, right? But where the shear force is, where the shear stress concentration is more, where there is a sudden change in cross section. I hope you are able to see, this is the position where there is a sudden change in cross section. Clearly there is a sudden change in cross section at the junction between flange and web. So at that point, generally I can say just after this is maybe I can say this is root radius. Just after root radius, you are able to see there is a possibility of bent leg. I can say the web of the web of this beam has got bent, has got flown laterally. The material has got flown. Why the material has flown to the sideward direction? I can say this is because of or due to stress concentration. Stress concentration. Because of stress concentration only this web crippling is happening. Okay, now the question is, sir, web crippling is happening at this level. Okay, definitely. So at this level, on what width of this on what width of this beam this web crippling is, we are able to see this web crippling, we are able to see on this width. I hope you are able to see this much width, because this is the dispersion. I hope clearly you can say. Mm, you can see this is the dispersion of the load from the flange till the end of the root radius. If you see the code, the angle at which this dispersion of the load is happening, I hope you had taken a beam in this way, right? So maybe because of high shear force at this end, maybe this is called as maybe section XX. I can say this is section XX. At this section XX only this crippling is happening. What is web crippling? So because of high stress concentration, the material at that level will fail in yielding mode, and it is able to flow plastically. That type of bent leg, that type of plastic flow of material is not at the junction between flange and web, is nothing but web crippling. Why we are calling it as web crippling? It is the shape of that bent sideward flown material is just like that of a crippled leg. I hope you understand what is crippled leg, a bent leg. So it is the bent has happened, the material has flown plastically at this region. So I can say at this region material has flown plastically. So when the metal has got flown plastically because of due to high stress concentration, the failure stress of the metal at this level is F5, because it has flown plastically. That means it has reached yield stress, no doubt at all. So this is the, I hope if you can see, if I draw a 3D view, I can draw, this is the width over which you are able to observe this web crippling on this width. What is this width? The width is B1 plus. Maybe I can write this one as N2. I can write this is N2. So what is the value of this N2, bro? This is already thickness of the flange, bro. This is already root radius. So for one vertical, the horizontal is 2.5. They are saying at what that angle, the dispersion of the load is happening to achieve this web crippling failure. In such case, for a vertical of thickness of the flange plus root radius, the value of this horizontal is n2. N2 is 2.5 times of thickness of the flange plus root radius. So I mean to say, if I want to work out, if you please excuse me, can I? Yes, sir, should be observed at some distance from the right support. It is observed at the points of maximum shear. I can say not from the right support, not from the left hand side support. It is clear, it is possible. This type of failure, dear Devalina, I can say this type of failure is possible at the points of maximum shear, where the maximum shears are possible under point loads or at supports where the maximum shear is possible. I hope your SM teacher might had already teach you what are the locations for maximum shear force. Don't you know the locations for maximum shear force? Just at the supports, common sense. And at under the point load, there is a sudden drop in shear force is there. So from the common sense, or not from the common sense, from the fundamentals of SOM, you are able to understand the locations of maximum shear force. This is possible at the locations of maximum shear force. I hope you know it can be right, it can be left, it can be in the middle also sometimes. It is depending on the type of loading dear. Right? Devalina? Right. Okay, okay. You didn't say right support. Okay, okay. So the common sense is it is at the points of maximum shear. I hope when a beam is given with different loadings is given, you know how to work out the maximum shear location and what is the magnitude of maximum shear force also. When the loads are moving, when the loads are static also, I hope you know how to work out that maximum shear force value and its location also, right? Yes. Okay. I don't want to discuss much that comes under analysis part or the strength of materials part, right? Yes, I don't want to comment much about that, right? I hope you know that one. I don't want to comment much, right? So now here the question is, now Devalina madam will ask us, sir, okay sir, that is fine, I am able to work out this is the maximum shear force is Vmax, which may be WL by 2 or some formula I may use for this example. Okay, now what is the web crippling strength? So what is web crippling strength? You tell me. The web crippling is happening over an area of this hatched portion. The area of this hatched portion is this width is B1 plus N2. B1 plus N2 and is acting over a thickness of the web. So what is web crippling strength? Web crippling web crippling design web crippling stress multiplied by, can I write the web crippling stress multiplied by area of web crippling, right? Area of web crippling. Can I write in this way? Common sense, right? From the fundamentals of SOM. If I write this one, you tell me what is the failure stress of this web crippling. Actually, the failure stress of this web crippling is F5 because the material is flown plastically to the sideward direction. So actual failure stress is F5. When yield stress is governing the design, what is the factor of safety? I don't want actual failure stress. I want the design web crippling stress. Design web crippling stress is equal to actual crippling failure stress divided by factor of safety. Factor of safety is 1.1. This is the design web crippling stress multiplied by area of the web crippling. What is the area of the web crippling, dear Devalina madam? Can you see? Can you directly write from this one? Yes, I hope you can directly write, isn't it or not? Which is B1. B1 is the width of the I can say B1 is the stiff bearing width. Maybe let me write. B1 is stiff bearing width of support. So stiff bearing width of support. So B1 plus N2. How I can write that N2? N2 I can write as 2.5 times of, I hope you had already worked out this N2, which is 2.5 times of thickness of the flange plus root radius. Can I write in this way, Devalina madam? Directly. Yes, this is how I can write. So maybe let me write here what is TF. Everything. So the TF I can write as thickness of the flange and R is equal to root radius. Root radius, this R value is exists for rolled sections. Rolled sections. But this R value is equal to 0 for built up sections, or I can say for plate gutters. If you see, the root radius is 0. I hope when you had taken one plate, another plate, if you are joining these two with the help of these two plates with the help of a weld, then the root radius is 0 in this case. R value is 0 in case of for welded or riveted plate gutter, I can say, or in other words, I can say for built up I section, this R value is 0 indirectly. We can write, isn't it or not? But this is the formula, dear Devalina madam, or I can say Adarsh Vishwakarma, right? Yes, Adarsh Vishwakarma or Devalina madam, I can say like using this formula, I hope you people are able to work out the web crippling strength. Will you accept that or not? Yes, Amber Datta. Hi, Amber bro. How are you? Hope you are fine and everything is working well. Right? You had seen the web crippling strength, right? So if you please excuse me, the same thing I just mentioned here, right? So maybe can you see this problem? Can you see this problem? Dear Amber Datta, bro. This is a problem which is given in 2019 in GATE. So they are expecting the web bearing strength. Another name for, sorry. So I can say like another name for this web crippling strength is also called as maybe web crippling strength or web bearing strength. Web crippling strength or web bearing strength. So it is a type of bearing failure that we can say, right? So now this is the question for you, right? Yes. Okay, okay. Let her. Okay. So can you go? Can you work out this question? A rolled steel I section is supported on a 75 millimeter bearing plate. I hope you are able to see. This is a stiff bearing plate width, and the width of that stiff bearing width, which may be called as maybe B1 or maybe B, it's up to you, which is bearing width, stiff bearing width, right? Stiff bearing width or stiff bearing support, I can say, as shown in figure. The thickness of the flange and web of I section are, thickness of the flange of I section is 20 millimeter, and thickness of the web, sorry, TW, thickness of the web is 8 millimeter respectively. Root radius, which is R, small r I can write, which is 10 millimeter. Assume material yield stress Fi is this much. So I can say Fi is 250 megapascal. I can say 250 Newton per millimeter square. So the question is, I hope you are able to see this question. As per IS 800 2007, according to limit state method indirectly, IS 800 2007 is based on completely limit state method. Not it is based on working stress method. Before 2007, it was based on working stress method. As per latest code of IS 800 2007, the web bearing strength, what is the web bearing strength is also called as web crippling strength. Web bearing strength and web crippling strength both are one and same. So okay, they are expecting it as a numerical answer type question. There are no choices. I am expecting answer from you guys, right? So I hope I already teach you web bearing strength. So write the formula. What is web bearing stress? Design web bearing stress multiplied by bearing area, or indirectly web crippling stress multiplied by crippled area of the web. So what is that web crippling stress? Fy, yield strength of the web by 1.1 into crippling area of the web. I can say B1 plus, this will happen, this is at this level, this crippling will happen here at this level, and the angle at which this dispersion of this load will happen for web crippling is 1 vertical to 2.5 horizontal. So I can write this is B1 plus N2. What is that value of that N2 here? Maybe I can say this is B1, and this may be, let me change the color better, B1 plus this is N2. Right? Maybe I can write B1 plus N2. N2 I can write as 2.5 times of thickness of the flange plus root. Right? Just try to substitute here. They are expecting this in kilonewton up to 2 decimals. So round off after point to up to 2 decimals. You round off and mention the answer. What is yield strength of the web brother? 250 by 1.1. Please understand they are expecting this answer in kilonewton, not in Newton. And after point up to till 2 digits, and at second digit must and should be rounded off. Like that, you need to type that numerical answer type. So multiplied by B1. So stiff bearing width, that B1 is 75 millimeter as it was given in directly in the problem, which is 75 millimeter. 2.5 times of thickness of the flange. I hope you are able to see thickness of the flange is 20 millimeter and root radius is 10 millimeter, right? So to 20 plus 10, I hope you, if you are able to work out, you are able to get 272.73 into 10 cube Newton. You will get, if you write this in terms of kilonewtons, 272.73 kilonewton. So in this blank or in this numerical answer type, you need to type as 272.73. This is how you need to work out, right? Yes, right, right. Okay, okay, okay. Don't get worried. You people are really nice. So can I move to the another type of web strength, which is nothing but web buckling strength. That buckling is also be happening because of heavy shear force, or maybe because of heavy concentrated loads, or because of heavy point loads, right? So if you please excuse me, guys, shall I teach the web buckling strength formula, the derivation, and after that a problem, right? Yes. So coming to web buckling. So coming to this web buckling, I can say, if you want, this is the theory so that you can work out this one. I just want to say this web buckling, why this web buckling is happening. Maybe let me write with another color. Why this web buckling is happening, man? Uh, yes, this web buckling is happening due to excessive shear force, or due to heavy concentrated loads, and when sufficient sufficient reduced T by TW is not there for web, or in other words, due to high slenderness ratio of web. This is happening due to high slenderness effect slenderness effect of web. So the common sense says is, when the slenderness effect of web, indirectly I may write as d by tw, is reduced, then obviously the buckling tendency of web will decrease. Then obviously what is going to happen, buckling strength will increase. Buckling strength increases. That is the common sense observation generally. Okay, right now. Okay, where this buckling will happen and all this stuff, let me take a figure and let me explain you at what level this buckling is possible and what is the reason behind that one. Let me explain with the help of a figure. I hope you are able to see a figure here. This web buckling, let me take a figure, like let me take a beam subjected to maybe uniformly distributed load. Here, if the web is needs to be buckled, the web buckling is possible at maximum shear forces. The points for maximum shear forces are generally at supports or under heavy concentrated loads. I can say the points are at A and at B. The maximum shear force is possible. So okay, at A, because of high shear force, maybe here I can say this pressure is reaction from supports, which is equal to shear force at the support indirectly, right? But instead of point load, that point load was has got distributed over certain width. The width of the stiff bearing width here is B1 is the width of the strip bearing width. Let us suppose. Now, here you can take at this cross section XX. Maybe let me take this is the section at this cross section at the support. If I take the cross section is section X. So I can say this is section, and I take this section XX because of due to huge shear force. I can say due to high shear force and high value of d by tw, which is more than 67. I hope when d by tw in your previous class I already mentioned, even the depth of the web by thickness of the web, when d by tw is more than 67, the web will fail in shear buckling or buckling mode. Of course, in order to stop that buckling, we will use stiffeners. That's a different issue. We will talk by the time we are starting the plate gutter. But anyway, right now I am talking about web buckling strength. Na? Okay, that web buckling is coming into picture because of high slenderness ratio of the web. That means I need to reduce the slenderness ratio of the web. Indirectly, the depth of the web by thickness of the web should be reduced. That means thickness of the web should be increased indirectly. So I should provide sufficient thickness of the web. That is the common sense. Okay, let us suppose if the buckling is possible, at what level that buckling is possible. Generally buckling means lateral bending. Here which element will bend laterally? Here this web, this is flange. This web will buckle to the sidewards, right? The maximum sideward deflection is happening at this neutral axis level, or I can say at neutral axis level or at the mid level only. Maximum sideward displacement of this web is happening due to this high shear force when d by tw is more than 67. That is for sure. Okay, now the question is, sir, the web buckling may mostly is happening at the mid level na. At this mid level in 3 dimension, what is this width over which this web buckling is happening? From this one, if you take the load dispersion, generally will happen if you take IS 800 2007. Load dispersion in case of web buckling failure will happen at an angle of one vertical to one horizontal at an angle of 45 degrees. This is how the load dispersion will happen. So if I draw a line at the mid level, I hope you are able to see. If I draw a line at the mid level, this is the width. This width is nothing but this is the effective width, which is this is the effective width over which we are observing buckling action of the web. So what is that value? This is b1. Maybe this is n1. So I can write this width is definitely b1 plus n1. All right, so this width is b1 plus n1, and that buckling area is this hatched portion na. So the thickness, this width, the width over which that buckling is happening is b1 plus n1, and the width over which that buckling is happening on the thickness of the web, maybe I can say directly here as uh, this is definitely thickness of the web, we can say. So the area of the hatched portion are the effective area for this web buckling. The web buckling area is b1 plus n1 into tw. I can say effective area of web buckling equal to b1 plus n1. How I can write this n1? For one word n1 I can write this is already d by 2. This is already overall depth by 2 because the neutral axis generalized at half. At a distance of d by 2, if I take, then obviously what is the value of this n1? So this n1 is this n1 is for, I hope you can see from this one, tan 45 opposite side d by 2. This adjacent side is n1. So tan 45 is 1. So you can write n1 is equal to definitely d by 2. So I can write b1 plus n1. N1 I can write as d by 2 into thickness of the web, where b1 stands for Stiff bearing width, everybody can write. Second, even stands for stiff bearing width. I hope everybody knows that one. And I can write D. D stands for overall depth of the section. Overall depth of section. So that from the profile of that I section, ISMB 400 something, you can get that one. What is TW? TW stands for thickness of the web. Okay, now it is okay. Now this web buckling is coming into picture because of buckling action of the web. Generally you tell me buckling will happen into picture because of compressive action, because of compressive action, because of compressive action in this direction for web. Okay, you can treat the web as a column which is fixed bit. Here you can treat, here it is fixed, here it is fixed, almost fixed, right? So you can treat like what is the web buckling strength. So I hope you can see, you can easily write here, web design web buckling strength is equal to design web buckling stress, which we call it as design compressive stress indirectly. Because of that design compressive stress, that is equal to this buckling stress here, design compressive stress of web. Okay, so I can write FCD of web multiplied by area, I mean effective area of the web buckling. I hope you can write this as effective area is AE. Maybe I can write this as AE. This AE is, now the question is, sir, I know AE you had written as a formula. How to work out FCD of the web, design compressive stress of the web, or you treat the web as a column here, right? Effective width part, sir, not getting this, sir. Okay, what is this effective width part? Okay, you are, dear Ambar Datta says like, Ambar Datta is not able to understand what the effective width over which that web buckling is happening. Dear Ambar Datta bro, if you please excuse me, can I rub the screen here? Maybe. Yes, I just want to rub the screen here, dear Ambar Datta bro. Okay. Maybe erasing on all this, right? Maybe if you had taken, this is how, maybe a P in side view or front view, you can understand. These are the flanges, right? Now you tell me where this web, this is how the width of the support, this is how here it is width of the support. Now because of heavy load here, where is the maximum shear force is possible, dear? Maximum shear force is possible at the supports. So here I can say, here also I can say, if web is buckling, I hope this is web. If web is buckling, will the web will buckle from this end to this end? Will the web will buckle? No, from this end to this end, the web will not buckle throughout the length of the beam. The web will buckle only over certain width, only here, only to this extent. Maybe I can say only to this extent. Maybe I can say this portion of the web, which is hatched portion, maybe this portion of the web only will buckle. But in the middle portion of the web, I hope in the middle span of this web will not buckle. The web buckling is happening under the points of maximum shear forces here. Now the question is, sir, at what is the width of the web? I hope you are able to see that. This is what is the width of the web. This is the effective width of the web. This is the effective width of the web over which you can observe buckling. Okay, over which you can observe buckling. As I already done that, that circle is here, that circle is here, I mean, so this to this length, this is already b1, this is effective bearing width is b1 until this width. What is this width? So to work out this width from here to here, the name of this width is maybe n1. How to work out this n1? Yes, is that okay, dear bro? So you, I hope you are able to understand, like web buckling will not up will not happen over the entire length of the web. It is not possible over the entire length of the gutter. Web buckling is not possible. That is possible under the locations of maximum concentrated point loads or maximum shear forces that are generally at supports. So that's the reason why from the support we are showing that. Okay, is that okay? Right. Yes. Now, so that width at which it is dispersing is for one vertical to one horizontal. So because of which you are able to work out. So the value of AE is B1 plus N1. Yeah, N1 is how we can write D by 2 times of into thickness of the web. I hope this is happening at this mid level. Na? In 3D view, I can show this is the effective width of the web in 3D. In 3D, the same, which is B1 plus N1 is in three dimension. This is in the side view. This is from here to here. This is in side view. It is B1 plus N1. Right. Yes, yes. Entire length it is not possible because in entire length is that heavy compressive force is coming from flanges to web. No, from heavy compressive force in the form of shear is not coming on the entire length. That is happening only at the supports only. Clearly, it is you are able to see that, right? So it is common sense, like everybody will understand from the basic fundamentals of structures that buckling is only possible at the supports are under maximum shear forces or under maximum concentrated loads, right? Now the question is, okay, so what is web buckling strength, bro? How we can work out web buckling strength? The web buckling is happening because of design compressive stress, which is the FCD. This is just you treat the web as a column running between flanges and the length of the effective length of the column. So FCD multiplied by, I can write effective area AE. Now how to work out FCD? So I hope you know how to work out FCD. You treat this column. What is the cross section of the column? The cross section of the column is just like that of a rectangle only. I hope you are able to see is how this is a rectangle only. So when FCD, I hope you can say what is the buckling class of this cross section? Class C. For class C buckling class, what is KL by R minimum? You need to work out KL by R minimum. What is this KL? Effective length of this web. This is it is spanning, it is running or spanning between flanges. The effective depth is the depth of the web. So out of depth of the web, here there is fixity, here there is fixity. So I hope you can say this is the effective length of the web. You can clearly mention. So what is this is effective length of web. So how I can say that effective length of web? The overall depth is depth of the web, for example. But out of that one, here at end is fixed and here at end is fixed. So the K factor is almost zero point 0.7, 0.7 times of depth of the web d by d divided by r minimum. What is r minimum of this hatched portion? I hope you are able to see. What is this about this axis only? About this axis only for this buckling area of cross section, what is the minimum radius of gyration? R minimum is the minimum radius of gyration of the buckling area of the cross section. So what is this R minimum? Can you find out R minimum for this hatched portion? I hope you can. This is B1. So R minimum is square root of I minimum by A. So if you do this one, I can write this one as square root of B1 plus N1 into TW by 12 divided by B1 plus N1 into T. So I can write it is just T by thickness of the web by root 12. Thickness of the web. This is maybe clearly I can write this as, right. Sir, initially I was just saying, okay, okay, they have not. It's not at all a problem. It's not at all a problem. It's okay. It's okay. You are awesome. Okay, don't worry. Okay, thickness of the web. Okay, let me concentrate on teaching. Okay, it's okay. It's not at all a problem. Right. So thickness of the web. So I hope for this hatched portion, what is the R minimum? Can you find out R minimum for this hatched portion? This width is B1 plus N1, and the R minimum for that hatched portion is, I hope you can get this as plus N1 into T. So you can get as TW by root of 12. So you can directly get it as 2.42 times of depth of the web D by TW. So try to work out for a slenderness ratio of, for a KL by R minimum of 2.42 times of D by TW. The same thing in some of the books, if you see, for a slenderness ratio of, maybe in some of the books, those people may have also written this as, for a slenderness ratio of KL by R minimum, which is equal to 2.5 times of depth of the web by thickness of the web. For this slenderness ratio, for Fy is equal to 250, and for class C type of sections, I hope you can see from table 9C. I already teach you at the time of columns. To memorize, or if you don't memorize, I had clearly mentioned there. So how to work out design compressive stress for a column FCD? So it depends on the buckling class of cross section. The buckling class of cross section for a rectangular shape of the cross section is, it's class C. For from table number 9C, you are able to work out FCD, right? So after you work out FCD multiplied by AE, or by using Robert Parison approach equation. A big equation is there. Using that big equation also, you can work out this FCD. So, but out of that equation and tabular form is the best way. Out of that, out of those formulatic way and tabular form way is the easiest way. So you using table 9C, you can work out FCD. So this is how you can work out this web crippling strength, bro. Is that okay? You know FCD, you know effective area, right? How to work out this effective area? I hope this is the effective area. Right? Depth of 1 2.42 times of depth of the web by thickness of the web. You can write in that. So can I hope you understood how to work out the web buckling strength. You how to derive that formula also. You understood, right? So if you please excuse me, shall I start the plate girder? The two checks are over. Web buckling strength, web crippling strength. How to find out those strength you had observed, right? So if you please excuse me, before I start the thing, before I start the plate girders, I just want to say, for any flexural member or flanged member, I can say uh, should be safe in secondary checks. Like should be safe in web buckling and web crippling. Let us suppose, for example, for a section for which you had designed, it is safe with respect to flexural strength. It is safe with respect to shear strength. If it is say it is say safe with respect to deflection check also, but it is not safe with respect to maybe web buckling or web crippling. In such case, what you need to do? In such case, you need to redesign, right? Or another way. In such case, for example, if not maybe if the a section is not safe in either web buckling or crippling, redesign the. Some people will say, sir, another time redesigning the section is a difficult stuff. So I will keep the section size as same. Is there any other alternative how I can stop this web buckling or web crippling? So you can stop. Question is how to stop web buckling or crippling. Answer. What are the answers? Uh, Design the section with D by TW less than 67. This is the answer of possibility number one. Possibility number two. What is the second possibility, bro? Possibility number two. Yes, Ambar Datta says stiffener should be used. Second possibility is more feasible or more economical. I can say that second possibility is more economical. So I can say second one is maybe I can say uh, hmm, use the design of use the design of stiffeners which will stop web buckling or crippling even with the high d by double value. Okay. The second alternative is more economical, I can say. More economical. First you can do, it's not at all a problem. When you do in this way, government of India will lose its funds. If you had gone for first alternative, like government of India will lose its funds, right? Whatever the design that you are doing must and should be safe. In addition to its safety, it should be economically viable also. That economical viability will come into picture from the second option. Okay, right? Yes, yes, right. So if you please excuse me, I just want to start with plate cutter. Is that okay? So I just want to rub the screen. Okay, I just want to start with the plate cutters. Of course, in plate cutters only you will do this check for web buckling, check for web crippling, and all this stuff. Before I start that plate cutter, I just want to say one thing. Right now, the question for some of the guys is that even for 1 second, even for our rolled sections, even for all rolled sections, I don't understand what are this editing. It is coming. Even for rolled sections also, even for rolled sections also, whether the check for web buckling and crippling are required. That is the question. What are rolled sections, brothers? I hope you know the section sizes and shapes that are directly available in market. So when the section sizes and shapes that are directly available in market, for that sections, we try to design the sections in such a way that I can say the answer is for the sections we can design the sections in such a way that I can say answer is not required. What is the answer not required? What is the reason behind that one? Due to due, as for rolled sections, the manufacturer always keep depth of the web by thickness of the web, depth of the web by thickness of the web less than 67. In such case, no possibility of web buckling or crippling. That means generally this web buckling or web crippling is required whenever we use it to use built up beams. So note check for web buckling or crippling is required when we design using built up sections. So in case of built up sections, if it is used as a beam, right, just like the tough plate gutter or anything, I will talk about built up. In such case only check for web buckling, check for web crippling are required. If it is a rolled section, for that rolled section there is no need for any check of web buckling strength or web crippling strength, because d by dw is less than 67. So in such case no buckling or no web crippling is possible. So I just want to rub the screen. I just want to right now. I just want to start the plate cutter, brother. Okay. So okay. So yes. Maybe. Now the question is, sir, okay, sir. So what is a plate gutter? Plate gutter, how we can define the plate gutter, man? Plate gutter is a flexural member only. It is a flexural member employed for supporting heavy loads. It is a deep gutter. It's a heavy gutter employed for supporting heavy loads over long spans. So flexural member, which is fabricated, which is it's not a rolled section. It's a fabricated cross section. It's a fabricated cross section uh, done by combination of flange plates and web plates. Flange plates and web plates in the form of I section to support heavy loads over long spans. In such case, in case of heavy loads under long spans, I can say bending moment and shear forces are very high. And bending moment and shear forces are very high, rolled section are not sufficient, because the roll maximum size of rolled section that is available in market is ISHB 600 only. Beyond 600 depth, if I want to go for higher depth of I section, in such case more than 600 millimeter depth, I should definitely go for, I can say, fabricated cross section, which is a built up section is required. So I can say built up fabricated uh, I section is required. I section is good in resisting the flexural loads that you had already seen. Fabricated means it is manufactured. Fabrication means manufacturing. So right. So yes, some people are asking, fabricated is manufactured. Okay, just by order, special order. They may be manufactured by special order, because that size of plates, that size, that much depth of I section, that much plate width, but that much flange plate width, that much depth of the I section is not available in market. That type of sections are manufactured separately by special orders, that is fabricating. Okay. So I hope this is the flange plate. I hope clearly you are able to see. This is the flange plate. Let me show. This is the flange plate. This is the web plate. The denominator. This is the web plate. So how we are manufacturing this flange plate and web plate? So the flange plate of the flange plate of required width with required thickness, web plate of required width with required thickness. We will generally weld each other. I hope you are able to. This is how we can weld. Right. Okay, okay. Please change the ink color. Okay, okay, okay. Okay, 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 okay. Definitely. Maybe I won't use the green color. Maybe. Right. Definitely I may use this blue. Manufactured. This is the color that I can. Is manufactured by special order to industry from us. We will make the drawings and we will send them. They will manufacture that cross section in that particular way. Yes, not visible at top. I hope you are able to see this now, right? So, okay. Are you able to visible now? Right. Yes. Right. Okay. So, okay, because the thing is, in order to resist higher bending moment, I require higher moment of resistance. So, as higher bending moment means require higher moment of resistance. Higher moment of resistance to get higher moment of resistance, higher moment of inertia is required. How you can increase the moment of inertia of this I section? By taking higher depth of web. When a d depth of the web has got increased, thus that is the more area is thrown away from this neutral axis. So I can say is required, means I can say d is increased, right? That's what you can say. By the time you are increasing, please be, please keep in mind, like, in order to avoid web buckling or web clipping, try to keep d by tw should be less than or equal to 67. Then in such case, no buckling, no web buckling, no web crippling failure will come. For the same roll, for the same fabricated section like this, I hope you are able to see. For the same fabricated section in this way, if you see, for the same built up section with d by tw more than 67, then in such case that fabricated section is prone to web buckling or web crippling definitely. So, right. So in such situation, especially to have to require higher moment of resistance, generally in such situation, either first thing is, I can say, two I sections kept side by side, either built up section by manufacturing two I sections side by side. Maybe I can say two, use two or more regular available sections. This is one I section that is available in market, is one way to increase the moment of inertia. This is another I section that is available in market. By using two I sections side by side in this way, and by keeping these two I sections as a single unit, by keeping plates together, by using top cover plate and bottom cover plate together, maybe with the help of weld or anything. If I do the section in this way, maybe some people will also ask us how we will do. Maybe we will bolt here. Maybe with the help of bolting we may make a connection, or some people may do welding. It's up to them. I hope this is a built up section using two or more regular available sections side by side. If you do in this way, this is one way of designing the section. But if you use two sections side by side, this type of section may not satisfy deflection limit. But here for this section, generally about this is zz axis, this is generally yy axis, this zz is the bending axis. So I hope you know how the transverse load is applied, bro. I hope you know this is how the loads are getting applied. Now the bending deflection will happen generally about ZZ axis. So to reduce deflection about ZZ axis. Here in this case, IZZ is less than IYY, but I require IZZ more, right? To reduce deflection about ZZ axis, I about ZZ axis should be more than YY axis. It may be safe with respect to flexure, no doubt, but it may not satisfy the deflection limit, or I can say may not satisfy serviceability criteria. May not satisfy serviceability criteria. This is first option. In that case of heavy bending moment, long spans, this is one possibility, right? In this possibility, the problem is deflection check we may not satisfy. Second check, what is the second possibility? I can say possibility one. Maybe let me change the color. This is possibility one. In case of higher bending moment with long spans, in case of higher bending moments with long spans, possibility number one is not economical, and there is some issue of the serviceability is also there. That's what you can understand. What is possibility number two? This is possibility two. Possibility two is we can use a fabricated plate gutter. We can manufacture our own plate gutter. So that gutter is manufactured by flange plates and web plates. That type of gutter that we are using is nothing but plate gutter, because that gutter, that deep beam that we are manufacturing by the combination of flange plates and web plates. By manufacturing a plate gutter, wherein the designer has the freedom to choose the size of webs and flanges, or third possibility is use a steel truss. This is possibility three. Three possibilities are there. Second possibility is okay. Second possibility I can say is steel truss. Generally we can go for steel truss, definitely, no doubt at all. Steel truss is also a better option, but generally I can say maybe what you call for economy purpose. If you ask me in terms of economy purpose, generally, okay, generally I can say uh, this plate gutter, this possibility to plate gutter is used for spans between 20 meter to 100 meter. Possibility 3, that is steel truss bridge, steel truss, steel truss bridge. Steel truss bridge we can do that is economical when spans are more than 100 meter, then that is preferable. If the bridge spans is beyond 20 meter and less than 100 meter, generally the best possibility is plate gutter in terms of economy. So that's the reason why, if you had seen, most of our railway bridges are made up of this plate gutter. One second. That's the reason why I say that is the reason why most of our road bridges or railway bridges, when it is made up of steel with having spans more than 20 meter and less than 100 meter, are made up of most of our bridges. Railway bridges are designed by plate gutter. If the span of the bridge is more than 100 meter, in such case we can design the bridge as a steel bridge. That's a different issue. I mean, steel truss bridge. That's a different issue. Now, Now can I move to the next slide? So I just want to show in the next coming slide, like some people will also ask me, sir, the plate gutter is a very deep high section, na sir. Generally, what is the self weight of that beam? What is the self weight of the plate gutter? How we can evaluate the self weight of the plate gutter generally, or how we can do that? So yes, this is. I hope you are able to see. This is a plate gutter. This is a plate gutter railway bridge. I can say this is an I section. This is an I section. These are stiffeners. I hope you are able to see. Maybe these are stiffeners. These are vertical stiffeners. That's a different stiffeners. Why stiffeners are used, pen, to stop web buckling or web crippling. Railway bridges over small drainage, right? Just over small drainage, and even when the span is up to 100 meter, you are free to use. When the span is more than 100 meter, in such case of railway bridges, you might have seen the span is more than 100 bridges. The same railway bridge was manufactured by a truss bridge, by a steel truss bridge, right? Yes, yes, by a steel truss bridge. When the span is more than 100 meters, okay, right. So when it is a vertical stiffener, I hope you can say this is flange plate. This is, I hope you are able to see this web plate. Over this web plate, this is the rail over which the train will move, maybe I can say, right? So this is how I can say. And this is the flange plate. And these are all these are in vertical direction, na? These stiffeners are called as vertical stiffeners. Sometimes even after providing vertical stiffeners also, even by the time the web buckling cannot be stopped. In such case, when web buckling is still persisting after we provide this vertical stiffeners, then in such case I can say like horizontal stiffeners in this way is also required. Horizontal stiffeners are used when the web buckling phenomena or web crippling phenomena is even more. When it is not getting stopped just by vertical stiffeners, then even I can provide this horizontal stiffeners also. Simply, what are stiffeners? Stiffeners are elements provided in plate gutter, in gutters I can say, gutters, to stop web buckling or web crippling. How we can say, right. Now moving to the next slide. Can I move to the next slide, Devalina? Right. So before I move to the elements of the plate gutter, I just want to say like, sir, okay, in case of plate gutter, before I move to the elements of plate gutter, I just want to say here itself. Let me just rub the screen, erase all ink on the slide. Okay, before I go move to that one, I just want to say like, sir, okay, how this plate gutters, the plate gutter can be a welded plate gutter, or it can be a riveted or bolted plate gutter. For welded plate gutter, how we can show that welded plate gutter? This is how the flange plate, this is web plate, and again this is flange plate. Okay. I may go for welding here, welding here, welding here, and welding here. In this way I can go, right? So maybe this is welded plate gutter. Of course, if I want to show in 3D view, maybe I can show it in direction. Welding is welded plate gutter. Some people will come and ask us, sir, I just want to go for riveted plate girder. How I can do? With the same section, this is an I section. This is I section is there. Okay. Just this is flange plate. Next one is web plate. Next one is flange plate. After I should not go for welding. I should go for riveting. How I can go for riveting? Maybe I hope you can see clearly with the help of an angle section. If I had gone here, unequal angle section. If I had gone for an unequal angle section, maybe I can go for welding. I can go for bolting or riveting here. I can go for bolting or riveting. And similarly here also to connect between this flange and web at the bottom. Here also I can go for an angle section. Here also I can go for an angle section. And I can go for bolting. Here also bolting or riveting. This is how we can go. Now this is welded plate girder. This is bolted plate girder. Now some people will also ask us, sir, this generally in case of beams, na, as the self weight of the beam, what is the rolled section? That rolled section self weight is available in what you can say, the rolled section that is available, the rolled section that we are considering for design. For that one, the self weight is available in steel tables, sir. Like IS handbook number one, that all the self weight of that rolled section is available. But this is not a rolled section. This is a this is a fabricated plate girder. In this case, how to find out the self weight of this girder? So I can say self weight or self weight of the welded plate girder. I can say weight of welded plate girder is equal to capital W by 400 kilonewton. Weight of bolted plate girder. For bolted plate girder, the weight or self weight is capital W by 300 kilonewton. Everybody will ask us, sir, what is this capital W? This is an empirical rule. Don't think like this is an exact value. This is an empirical rule. How we will consider the dead load of plate gutter? Because in the design of the plate gutter, you should consider the self weight of the plate gutter also. If you are designing for welded plate gutter, you need to take it as W by 400. In case of bolted plate gutter or maybe riveted or riveted plate gutter, in such case W by 300, because here the weight is high on this bolted plate gutter, whereas welded plate gutter weight is less generally. Now everybody will also ask us, sir, what is this W? W stands for total superimposed load in kilonewton. Total superimposed load in kilonewton. So I hope you know what is that one, total factored superimposed load. So what is superimposed load? That maybe I can say total live load. Total factored live load. Total factored live load, which is double W, we can take in that way. Right, sir, what is 400? These are all empirical rules. So I am saying these formulas are empirical formulas to ascertain, to roughly find out. Thumb rule, I can say. Empirical rule means thumb rule. There is no proof at all. If it is a rational formula, there is a proof is there. But these are by experience. I can say these are the load. These are self weight. How we can find out the self weight of the plate gutter? That 400 is a value. That 300 is a value. Okay, these are all empirical formulas, or I can say thumb rules in order to find out the mass or UDL or the self weight UDL of the welded plate gutter. Weight UDL, weight of plate gutter in kilonewton per meter. This is W. That is 400, 300s are, so those are there. I cannot say 500, 600. By this is by rough experience we are giving this one. I hope you understood the terminology called as empirical formula or thumb rule. Okay. Why 400? Why can't it be 200? Why can't it be 100? So by experience, they had created this form. This is how almost, because if you want to work out the sulfate of the section, you need to design that one first. After finalizing the fixing the sections only, you are able to say. So after designing the sections, if you see, when compared to the total factored superimposed load, its value is W by 400. Like that, some range was given. So we are using that empirical formulas there, Devalina. Just use that one. So coming to, for example, if you are saying on a plate girder, this plate girder bridge of span maybe 30 meter, and the uniformly and I mean the live load that is moving is, maybe I can say, because on plate girders the loads are generally moving. The live load that is moving is maybe 30 kilonewton per meter. This is factored load, for example, factored load. So what is total factored load? Total factored load, it is equal to, try to convert this as a point load. So 30 kilonewton per meter into this is 30. So 30 kilonewton per 30. So it is 30 kilonewton per meter into 30 meter. So I can say 3 threes are 9, 900. So this value of this W is 900 in that example. Just to calculate self weight. Clearly, I had written there. Na? I had clearly written there to calculate the self weight. Yes, that is an empirical formula. Please understand, it's not a rational formula. If it's a rational formula, I could have derived that one for you. You are asking this very number of times. That is to roughly evaluate the self weight of the plate girder. Okay, at the starting stage. Yes. Yes, dear Devlina, can't we take the weight density of steel? Dear Devlina, you tell me, by the time you are designing the section size of plate girder, do you know the volume of the plate girder? Do you know only the length? Do you know the cross sectional area of the plate girder? You don't know the cross sectional area of plate girder. Then how you could consider the self weight of the plate girder, dear Devlina, at the time of designing? At the time of designing, you need to fix the dimensions. You don't know. Being a design engineer, it's your duty, right? You don't know the cross sectional area, you don't know the dimensions of the flange plates, you don't know the dimensions of the web plates, then how could you consider the cross sectional area, right? It is impossible. So at the starting stage, in order to consider some self weight of the plate cutter, this is the formula, thumb rule that we are using. Is that okay? Right. Right. So can I move to the next slide? Of course. Yes. And I just want to write one more thing. So can I rub the screen? Right. Some people will say like, sir, when D by TW, when D by TW is increasing, then what is going to happen? Then I can say when D by TW is increasing, the web plates are leading to local buckling failure before before yielding failure. So how many types of this local buckling failures are there? So coming to the types of local buckling failure. Local buckling failure. Just coming to this local buckling failure, maybe I can show you here itself. 1 second. Oh, okay. Maybe, yeah, don't worry. I will draw the sketches. Coming to local buckling failure, there are three types of local buckling failure are there. One is here buckling failure. Second one is horizontal or longitudinal buckling failure. Third one is vertical or bearing buckling failure of web plates. This is how we can say, right? Okay, now everybody will say, sir, when this shear buckling failure, how it will happen? Can you show that one? Show how horizontal or longitudinal buckling failure will happen. How vertical bearing or buckling failure of web plates will happen. So when these three are possible separately, right? Sorry about right. Now, in order to show these three different types of failure, I just need to draw the sketch of this plate gutter. Very quickly I will draw rough sketch only. Okay, very quickly rough sketch I will draw, and I will show, I will take an element. I hope to understand this shear buckling failure, okay, should understand the concept of stress analysis, especially by a general state of stress representation from SOM. That concept is required. Anyway, I will show that. Uh, this is how an I section is there, right? This is cross section, and if you take, this is the longitudinal section. Okay, this is how the longitudinal section is. I mean, along the length, this is how it is there. There are few vertical stiffness are there, intermediate vertical stiffness, an intermediate, another intermediate vertical stiffener. There is another intermediate vertical stiffener. Now, you tell me this where the supports are there. The supports are at these ends. This is a hinge here. This is a roller here. Maybe is a hinge. Is that okay? Hinge and roller. Now they are saying the first type of failure is shear buckling failure. That is shear buckling failure. If I take a small element here, okay, I can take small element here at the mid level. At this mid level, bending stresses are zero. Only shear is dominant at the mid level, right? So this is the element. If I take this element, right? If I take this element here, maybe if I take this element, right? What is the direction of stresses? This is the an element which is under pure shear. So at this mid level, bending stresses are zero. Only pure shear stresses. The shear buckling is due to transverse loaders. Horizontal buckling is due to, their horizontal buckling is because of axial compressive action, because of bending. So biaxial bending moment. Yes, Devalina. That is because of bending action that is possible. Yes. Yes, that is because of biaxial bending or bending moment. Simply I can say because of bending moment that is possible. Now I hope you had taken this element. Right now at mid-level bending stresses are zeros. Right, there are no direct stresses are there at the mid-level, and only pure shear is there. If I take pure shear, I hope your SM teacher might have already shown. This is how pure shear is existing. So when this is how this pure shear is existing, and vertical buckling failure is due to reaction from supports. Yes, vertical buckling is due to reaction from support. Yes, yes, Devalina. One second. So let me show how this shear buckling is possible. Now, if you had taken this element, this is how the state of stress is represented. I hope clearly this is an element that is taken at this mid level only. This is how the state of stress is represented. Now, after the state of stress is represented, how this can deform? There is no, there is only in this direction tension is developed. In this direction, along this one diagonal, tension is developed. Along this diagonal, compression is along this diagonal, tension is developed. Along this diagonal, compression is developed, right? So I hope you can see the same element has got stretched in this way. same element has got stretched out in this way. That means if you take for this line, maybe I can say this diagonal, oh, this diagonal here in this in this direction diagonal, this is under compression. Diagonal is under compression. This diagonal is under tension, right? So if because of compression, I hope you know buckling is possible. Generally people will think like, so because of shear action, how this buckling is happening? Because of this pure shear element, one diagonal is under compression, another diagonal element is under tension. So I can write note, due to pure shear and one diagonal is under compression, whereas another diagonal is under tension. There is no problem, especially uh, there is no problem, especially in this direction, because it is under tension. Now, in this direction, it won't buckle. So only it is compression is possible in this direction. Na? So I can say in this part here, especially there is a chance like the buckling is happen along in this direction, right? So I can say like also shear. This is what is the other name for shear buckling failure? This is called as shear buckling failure. What is the another name for this shear buckling failure? I can say another name for the shear buckling failure is also called as diagonal compression buckling failure. Diagonal compression buckling failure. Generally, how to stop this shear buckling failure? How to stop this shear buckling failure? I can say no shear buckling failure in web is possible when d by dw, no shear buckling in web when d by tw, depth of the web by thickness of the web is less than or equal to 67. So in the design itself, try to select the web in such a way that the depth of the web, maybe this is the depth of the web, this is definitely thickness of the web. Depth of the web, try to keep depth of the web by thickness of the web less than 67 in order to stop this shear buckling, right? Right. Another way, the shear buckling can be minimized by providing stiffeners also, like vertical stiffeners, I can say. So I can say maybe, can I rub the screen? Can I rub the screen? The shear buckling can also be minimized. How it can be minimized? Can also be minimized by providing stiffeners. By providing wood stiffeners, by providing, I can say vertical stiffeners, by providing vertical stiffeners. How, why I'm saying only vertical stiffeners are very good for to resist this shear buckling? If I had taken this one, right? If you take this vertical stiffener here, there is vertical stiffener is there. This is the end. For example, this is how the element I had considered. Maybe this is how the element I had considered. Okay. Now I can say in this direction, this is under tension. In this direction, this is under compression, right? So the compression forces are in diagonal, na? So when this is a diagonal force in this way, the vertical direction force, it can the vertical force and this can be the horizontal force. The vertical component of this diagonal force is resisted by this vertical stiffener. So by providing vertical stiffener, the vertical component of this diagonal force will be stopped, will be resisted. So by providing vertical stiffener, so that one component of diagonal compression is taken care by vertical stiffener, and another component, maybe the horizontal component. The horizontal component is taken care by these flange plates. Horizontal component, and another component is uh, taken care by flange plate. So that's the reason why, to stop shear buckling, the best way is, if it is d by dw is more than 67, the best way is by providing vertical stiffness. That is the stuff, right? Now the second type of stiffener is about horizontal. Second type of buckling is horizontal or longitudinal buckling failure. I can say second type of buckling, which is horizontal or longitudinal buckling failure. So how we can mention about this horizontal or so I hope if you take an I section, maybe here take an I section, maybe because of heavier bending moment. I hope you can say, like, heavy compression force will act. Maybe heavy. This is in the compression side. Heavy compression force will act because of tension force. There is no problem. Because of heavy compression force in that cross section, I can say, due to compressive stresses, due to heavy compression force, due to bending action, bending action of plate girder by bending. I can say, like, the web plate, the web plate have a chance, to buckle. About which axis it will buckle, that is the thing. Now, about which axis? About this axis, and there is another axis. Maybe I can say, mm, maybe about this axis. This is ZZ axis, about YY axis. If you take, because of heavy compression here, this web plate have a chance to buckle. Of course, compression flange will also buckle. In addition to compression flange, this web plate will also has a tendency to buckle laterally. Maybe that buck this YY is the buckling axis of we can say buckling axis of web, due to due to horizontal longitudinal buckling, I can say, right? Is able to buckle generally, chance to buckle as with respect to YY axis. Why I can say with respect to YY axis, as IZZ is very very higher than IYY. Generally, the buckling is possible because of this compressive action here. It is possible about this YY axis, right? Now everybody said, like, sir, how this compression force and tension force are coming? Because of bending moment action, right? Moment to get sufficient moment of resistance, that the compression force is coming in compression zone. Sufficient tension force will develop in tension zone to provide sufficient moment of resistance. That moment of resistance is either compression force into lever arm, or generally tension force into lever arm. This you had already studied this type of thing in your concrete structures already. The same concept here, right? Now the question is, okay, so to avoid this one here, to avoid the buckling about this YY axis, if I increase, how I can increase the How I can stop the buckling about YY axis, brother? Can you people tell me? The question is, uh, question, yeah, how to stop horizontal or longitudinal buckling about which axis? About YY axis. The answer is simple. Increase the moment of inertia about YY axis, right? So to increase the moment of inertia about YY axis for web, because which one is buckling? The web is buckling, right? Is a web. So I can say the answer is increase moment of inertia of the web with respect to YY axis. Now the question is, sir, okay, sir, how to increase the moment of inertia of the web with respect to YY axis? It is very simple. So maybe I can say like, I hope you are able to see to this web, we had provided a stiffener. These are longitudinal stiffeners or horizontal stiffeners. If I had attached a longitudinal stiffener to this web, so by attaching or by providing longitudinal stiffeners to the web in compression zone, by providing, people will cry at me because they think like that color is not visible. By providing longitudinal stiffener attached to compression side of web, by attaching that stiffener to the compression side of web. I hope you are able to see the compression side. To the web, there is a stiffener is attached on both the sides. These are stiffeners. So I can call this as a horizontal or longitudinal stiffener. Horizontal, longitudinal stiffener. Is that okay? Right. Now the third case is, sir, how to stop this when this vertical or bearing buckling failure of web plates will happen. So coming to the third one, right? This question is the answer. So yes, right. Can I rub the screen? Dear Devlina and other persons who are on the online, can I rub the screen? Rubbing the screen. So coming to the third type of buckling, the third type of buckling is vertical or bearing buckling failure of the buckling. So when this vertical bearing buckling failure of these web plates are possible, so where there are concentrated huge point loads are there. So at heavy concentrated loads, or point loads on plate gutter, bearing failure, bearing vertical bearing buckling failure uh, chance is there. So how such, so stiffeners are to be provided. Stiffeners are to be provided under concentrated loads. Under concentrated loads or support. So under supports or under heavy concentrated loads, I can say stiffeners, vertical stiffeners are to be provided. Name of such stiffeners are called as load bearing stiffeners. Such stiffeners are called load bearing stiffeners. To tackle, I mean, first type of failure, to tackle shear buckling, to tackle shear buckling failure, vertical stiffeners. Second, to tackle horizontal buckling failure, tackle horizontal or longitudinal buckling failure. Which type of stiffener? Longitudinal stiffener is used to stop or to minimize vertical bearing buckling failure. Vertical bearing buckling failure. This can be prevented by using load bearing vertical stiffeners. This is the summary that you need to memorize or a note. Right. So now moving to the elements of the plate girder. Right. So what are the elements of the plate girder generally that we have, bro? Coming to the elements of the plate girder, we have, I hope you are able to see in this one. This is flange plate. This is web plate, right? Vertical stiffness, horizontal stiffness, maybe the plates, as the plate elements that are available in market. Indian rolled mills are able to produce at max a length of 7.5 meter, but the span of this plate gutter required may be up to 100 meter. In such case, I need to join flange plates, I need to join web plates also. That is joining of flange plates and joining of web plates are required, right? So what is joining of flange plates and web plates are required to achieve sufficient length, of plate girder, right? So in such case, that joining of flange plates is nothing but splicing. Joining means splicing. Splicing of flange plates, splicing of web plates. It is joining of flange plates, joining of web plates to achieve desired length. That's what I mean to say. So I can say maybe clearly here. So one is flange plate, second one is flange angles with or without flange plates for bolted or riveted plate girder. Flange angles are also there. Sometimes some flange angles are required by the time we want to do a design of bolted or riveted plate girder. And third one is stiffeners. Stiffeners are to stop buckling failure, buckling and crippling failure of web. So in stiffeners, there are so many types of stiffeners. Vertical, or another name for vertical, or transverse, or another name for one is stability stiffeners, right? So where these vertical stiffeners are used to stop shear buckling of web. Horizontal or longitudinal stiffener to stop uh, longitudinal buckling of web. Third one, load or end bearing stiffeners to stop bearing vertical bearing buckling failure of Splices means, so in stiffness these are the stuff. In splices there are two splices means joinings, or in our technical language we can call it as connections. Okay, you can say, or connection. What we will connect, if we connect it to flanges, or if we connect flanges, it is nothing but flange splicing. If we connect webs, it is nothing but web splicing. There is how many more topics left in plate gutter? Of course, tomorrow is all tomorrow. Totally, I require 6 hours to teach this plate gutter, right? So please excuse me. Tomorrow, another 3 hours. I mean, then the next class, next coming class, I will take another 3 more hours. I will take on plate gutter, right? Today the session is for 3 hours, and I think only 2 hours has over. So for 3 to 4 more hours are 4 more hours are required to complete the session, right? So joining, if I join flange plate, those are nothing but flange splicing. If I join web, it is nothing but web splicing, right? Now, okay, some people will also ask us, sir, okay sir, now the question is, you generally keep the, if this is a plate gutter, sir, if this is a plate gutter, you are saying in order to stop horizontal buckling, okay, you generally will provide a horizontal stiffener. You provide that horizontal stiffener that also in compression zone of the web. If this is the neutral axis, for example, where that compression flange you will provide that horizontal stiffener. I can say these are vertical stiffeners, maybe I can say these are vertical stiffeners, these are vertical stiffeners. But horizontal stiffener is provided at the first horizontal stiffener is provided. I hope you are able to see this is the horizontal stiffener. The horizontal stiffener can be in the form of either angle section or maybe a plate section, anything. This is the horizontal stiffener, where this horizontal stiffener must and should be provided in the compression zone. From the compression flange, it should be kept at a depth of zero point 0.2 times of the overall depth of the section. What is the overall depth of the section? Zero point 0.2 times of D, right? It's just knowing this theory of plate control which is being taught today is sufficient for objective examination. Maybe tomorrow is also required. Tomorrow also, oh, I will talk some of the theory, right? Yes, for objective questions, even more theory is required, right? So I will talk more and more theory tomorrow also, right? So please excuse me, if I want to work out in detail the entire design procedure of plate girder, it will take 25 to 30 hours. In detail plate girder, if I take, I used to take for university examination, including detailing and every part like flange splicing, web splicing, calculation, detailing and every part, if I take, it will take 25 hours. But anyway, for this competitive examinations I am teaching for 6 hours, which is the crisp I am teaching here. Yes. So the same, every reason, whatever may be the theory questions in plate gutter, you can expect only theory questions and the codal provisions. The theory questions and codal provisions you can expect for your objective questions in this plate gutter. You can for tomorrow's examination of work. Okay, right. So okay, so this is where this is the first question. Where this is the longitudinal stiffener. Where this longitudinal stiffener should be kept. The longitudinal stiffener should be the first longitudinal stiffener. First longitudinal stiffener should be kept at a depth of zero point 0.2 times of overall depth of the section from the compression flange. Compression flange. From the extreme fiber of compression flange, the first longitudinal stiffener should be kept at a depth of zero point 0.2 times of D. If I want to keep the second longitudinal stiffener, brother, okay, maybe second longitudinal stiffener, just because of one stiffener, we are not able to stop the buckling. In such case, if we are providing the second longitudinal stiffener, where I can keep the second longitudinal stiffener, I can keep the second longitudinal stiffener at the mid level. I hope you know at the mid level means. This is the second longitudinal stiffener I can see. Maybe second longitudinal. In the second longitudinal stiffener, okay, uh, where the second longitudinal stiffener is provided at the mid level of neutral axis. That is from the compression flange, it is at a depth of zero point 0.5 times of d. So these are the two clauses. Some people will ask us, sir, why you are keeping this this longitudinal stiffness? Why you are keeping only in compression zone? Why can't you provide in tension zone? The logic is very simple, bro. Because of compressive action, the buckling of web is happening. Buckling of web is happening. So I need to stop the buckling of the web by increasing the moment of inertia. So I need to keep these longitudinal stiffeners only in compression zone but not in tension zone. Because of compressive action only buckling is possible, right? So you can understand that one. These are two questions you may expect this stuff, right? Now the question is, uh, why splicing is required? Why splicing is required? The answer is the plates length of plates available from Indian rolling mills. Indian rolling mills is only how much? 7.5 meter. But the span required may be up to 100 meter or maybe 20 more than 20 meter. In such case, what shall I do? So, but plate girder are built for a length of at least 20 meter. So, web splice is used to join web plates. Join web plates. Flange splicing is used to join. Are all codal provisions are going to complete today? I'll try. I try to my level best to complete today. Right? So all flange splicing, I can say flange splicing is used to join flange plates. Now, so some people will say, sir, okay, sir, this is fine. Now the question is, sir, if I want to keep the economical depth of the section, let us suppose, I hope you know, right? Let me give, yeah, let me use this here. I hope you people are good till now in codal provisions. Now some people will also ask us, sir, okay, sir, what is the economical depth of plate girder I need to keep? What is the depth? Because on what basis I will keep the depth? The depth of the plate girder is a function of bending moment, design bending moment. Design bending. What is design bending moment? It is the maximum moment to be received. It is the maximum bending moment developed in the structure, right? It is the maximum bending moment developed in structure. Okay, if you see, I hope if you are expecting this derivation also, this is a rational formula, or we can even derive this one also. If you are expecting me to derive this, of course, but in this effective depth, d is equal to m k. What is the value? What is this K? K is depth of the web by TW. So you can fix your D by TW value for which you want to design the plate girder. Plate girder. Right. Now, generally, if d by tw is less than 67 times of epsilon, that epsilon w is square root of 255 by fi, yield strength of the web, right? This value is generally 1. So when d by tw is less than or equal to 67, it may be designed as an ordinary beam, because when d by tw is less than 67, no buckling failure. Buckling or no crippling failure. You can design it as an ordinary beam. So the design procedure will get changed definitely when d by dw is more than 67. Now the question is, sir, to get the effective depth of the section, you are saying like you fix your value of k, fix the value of k. You can work out the value of m. You know fi from this one. So how to fix? The question is how to fix the value of k for design of plate gun. Yes, yes. Of course, you can. We can even derive this one. This is a rational formula. I can even derive this one. It's not at all a problem, right? So, if you are expecting me to derive, I can do that for you. It's not a very big stuff, right? I can do that for you, right? It's a matter of 5 minutes, and I can do that for you. But anyway, I hope if you are expecting me, 1 second. Maybe derivation. Okay, before I start, I will derive this value of d is equal to effective depth is equal to m into k by fi whole power 1 by 3. I will derive that one for you also. It's not at all a problem. 1 second. uh, I just want to say, right, I just let me answer this question, and after that I will derive this formula. It's not a big deal. It's a very simple deal only, right? So how to fix? Based on, I can say, not based on serviceability, please understand, based on experience and by thumb rule. This question is not asked in your objective questions. Don't write this answer, the answer that I am giving here for this question for your objective questions. For your objective question, they will ask you like, sir, what is the D by DW ratio that you need to fix if you want, if you don't want to use the vertical stiffener, right? What is the value of D by TW based on serviceability criteria? That serviceability criteria is different. I am talking, this is based on experience and by thumb rule. Okay, so this is for practical designs. Okay, use this one. Okay, don't use this for your objective question. That's the reason why I'm saying for practical design only. Okay, so please be aware of this. Now I can say when d by tw is less than 67, in such case, design of design of beam with no stiffness. When d by tw is more than 67 and less than or equal to 200, design of beam with end vertical stiffness. Okay, maybe 1 2. So if you please excuse me, can I write the answer for this question? I mean, there are few more answers out there. When d by tw is more than 200, right? In such case, design the beam with end vertical stiffeners and with intermediate stiffeners also. Maybe I can say Let me rub the screen. Can I rub the screen? There, Devlina. Yeah. Can I rub the screen? Maybe the third one. When d by tw is more than 200 and less than or equal to 240, then in such case, design the plate gutter with end and intermediate with the end and intermediate. Here two stiffeners I used. I hope clearly you are able to see two stiffeners. One is end and another one is intermediate vertical stiffener. Let us suppose when d by tw is more than 250 and less than or equal to 340. Right, in such case, design the plate gutter with first criteria is end stiffener plus intermediate stiffeners, intermediate stiffeners plus end vertical stiffeners. I can intermediate vertical stiffeners plus one horizontal stiffener. Maybe fifth. D by TW, one horizontal stiffener. D by TW is more than 340 and less than or equal to 400. Last case. Okay. I can say plus not one vertical stiffener, two or more horizontal stiffeners you can use. And the code says like never design any sort of maybe sixth rule. This may be a rule that may be asked. When depth of the web by thickness of the web is more than 400, never design the never design the web of plate girder with higher value of d by tw more than 400. So the limiting value of d by tw as per code of practice, if I want to design the plate girder as per code of practice is also 400. So even though if you use area stiffener, but still your d by tw value should always be less than or equal to 400. That is the final conclusion that we can draw, right? Hi Aditya Verma, hope you are fine, right? Right? How are you, bro? Hope you are fine, right? So can I rub the screen? I just want to rub the screen. Is that okay? Devlina? Devlina, madam, is that okay? Right, right. Yes, okay, right. This is by experience. Please understand that one. Now, as I already promised, I will even derive this D, economical depth of the plate gutter. D is equal to m into k by fy whole to the power of whole to the power of 1 by 3. Yes, right. So I can derive this one by using this mm, empirical rule. What is that empirical rule? So from coming to economical depth, I can say moment of resistance. How you can say that moment of if I take a flange, this is the flange plate and this is the web plate. This is again flange plate. So how the moment is actually resisted from your strength of materials concept, the moment is resisted by flanges, right? So how you can write that moment of resistance M is equal to compression force into lever arm. Can I write in that way? What is the answer of compression force? By the time if this is the compression force, what every layer has got reached to yield stress. Now maybe I hope you are able to see. This is how. Is how the distribution of stress per plastic section, right? Maybe I can say clearly. So this stress is Fy. So what is the compression force? How you can work out this is Fy. How you can work out the compression force, man? Compression force is what on the compression zone area. What is the average stress acting? Average stress acting is Fy, and it is acting on an area of this is breadth of the flange. This is thickness of the flange, right? So I can write Fy into Bf into Tf multiplied by this lever. How you can mention about the lever? The lever between these two flanges is almost the depth of the web. So maybe D. So maybe D, where D stands for economical depth. So this is how I can write moment of resistance. But I hope you know from this one M, you can write Bf into Tf, you can write as M by Fy into D, right? But what is the economical depth of the gutter means? Economical depth of the gutter means the total weight of the gutter will be the total weight, the cross sectional area of the gutter will be minimum, then the total weight of the gutter will also be minimum. You can't change the length, but you can reduce the area. So that means if I take area, how I can write total area? It is two times of this is one, this is two. First area plus second area plus third area. So first area is BF into TF. Such type of areas are two times of BF into TF plus depth of the web times of this is thickness of the web, right? Thickness of the web. I am interested to work out this D. So how you can work out A is equal to two times of BF times of TF. How you can write M by Fy into D plus D times of TW. But here TW should not be there. So depth and TW, how I can make as a single way? I can make as a single way of both this depth and thickness. Consider, take d by tw as k. If I take d by tw as k, in such case the area A is equal to m by Fy into D plus here I can say D by TW. In such case, this is 1 by K times of this is D square. This is what I can write. This is the expression of area in terms of D. Will you accept this one? I had converted economical depth of the plate gutter is I will try to derive an equation for area in terms of T. In order to achieve economical depth, that cross-sectional area should be minimum. So in such case, if this is the expression, this expression cross-section, this expression of cross-sectional area, where A stands for cross-sectional area. If the expression cross-sectional area should be minimum, then first order differentiation of if I want to get minimum cross-sectional area, the first order differentiation of that area expression with respect to the variable d. So dA by differentiation with respect to depth d should be 0, right? So if you do that one, maybe I can say definitely you are bound to get. Maybe can I rub the screen? Can I rub the screen, dear Devlin? Is that okay? I hope you know from the fundamentals of maxima and minima, from differentiation, from calculus. If a function needs to be either maxima or minima, I want that the cross-sectional area should be minimum. In such case, that function of cross-sectional area A with respect to the variable small d, depth of the web, d should be 0, right? Yes. So maybe erasing all ink on this slide. Is that okay? So in such case, if we do, so dA by d of d, it is equal to 0. Means how I will get that expression? 2m by Fy, differentiation of 1 by d minus 1 by d square, I can write. So plus differentiation of k is constant, differentiation of d square. Differentiation of d square is 2d. So this is equal to 0. From this one, if you work out d cube is equal to m into k by fy. The d that we got, it will be definitely the economical depth. If we keep this depth, the cross sectional area requ- required will be less, right? In such case, we will achieve economy. So in such case, the d is cubed root of m into k by f. This is how you can get, right? This is from the fundamentals only. That's the reason why this is the rational one only. There is no need to mug up, but generally, instead of doing this much thing, generally, if you are able to memorize this one, that is very easier for you. Okay, right. Okay, this is how you can work out this economical depth, right? Now the question is, okay, sir, what is the minimum thickness of the web? So this is, please understand, this is the minimum thickness of the web based on serviceability. Based on serviceability aspect. Previously, especially Devalina madam or Aditya Verma will ask me like, sir, in your previous two slides before you had given the limits for D by TW, na? From that one I will work out the minimum thickness of the web plate, sir. But those D by TW limits are actually from experience. That is from experience. That is not just based on serviceability criteria. The serviceability aspects or serviceability criteria, these are the limits that are prescribed to meet serviceability criteria of plate gutter, so that the plate gutter will not fail in terms of serviceability. Like so, in such case, when transverse stiffeners are not provided, I hope you can see, when transverse stiffeners are not provided, when transverse in sense vertical, when vertical stiffeners are not provided, then d by dw epsilon value is always 1. I think I had already given you epsilon is square root of 250 by fy. This I had already given to you, that epsilon value is generally 1, because our yield strength of the mild steel, that is structural steel, is fy is 250 na, square root of 250 by 250 is 1 na. So every time you can keep this epsilon value is 1, right? When d by tw is less than or equal to 200, so from this one, you can say like web is connected to the flange plates along both the longitudinal edges. So along the top edge, and if I take, this is the web plate, if this is the web plate, maybe this is the flange plate, this is the flange plate. Here both the top flange, I hope you are able to see. Mm. I hope you are able to see uh, both the top longitudinal edge and bottom longitudinal edge. Both are touching, both the flange and web at the top level and at the bottom level. Both are touching each other, right? So web connected to the flanges along both the longitudinal edges. So when only the web is when web is connected to flanges along only one longitudinal edge, in such case d by w is less than or equal to 90, right? But generally we will try to design in this way only. We'll try to design the plate gutter generally by touching this web plate to along the top edge for the flange and along the bottom edge for the flange. In both the edges will get touched, right? So in such case, if you see, thickness of the web should be greater than or equal to d by, I can say, 200, where d stands for depth of the web provided. You should be depth of the web provided by 200. This is the minimum thickness of the web minimum to satisfy the serviceability criteria, to satisfy the deflection criteria indirectly. This is not practically useful. This criteria this is useful to satisfy the serviceability criteria. Questions may come from this. Okay, this you need to memorize. Like they may ask a question like, sir, what is the minimum thickness of the web plate in order to satisfy the serviceability criteria, right? For a depth of the web is maybe some 2000, right? In such case, what is the thickness of the web? The depth of the web is 2000, 2000 by 200. In such case, the minimum thickness of the web I need to keep is 10 millimeter. Like that, you need to answer, right? So can you see this question? This is an example how I just want to iframe. Can you see this question? In a welded plate girder, I hope it is seen. In a welded plate girder, the web plate connected to the flange along both the longitudinal edges. So along both the longitudinal edges, the minimum thickness of the web plate required by considering serviceability criteria for unstiffened plate girder. Unstiffened plate girder means no stiffeners are used. When no stiffeners are used, this is the criteria that I already mentioned you. When transverse stiffeners are not provided, when no stiffeners are used, in such case, what is the thing? Can you tell me what is the answer? So I can say D by TW, this value should be less than or equal to 200, right? So based on serviceability criteria, minimum thickness required for considering serviceability criteria, right? As both the longitudinal edges are meeting the flange plate or touching the flange plate, the depth of the web is, the depth of the web plate is 2400. So 2400 by thickness of the web should be less than or equal to 200. So in such case, the minimum thickness of the web, TW minimum, should be greater than or equal to 2400 by 200. So what is that answer? Should be greater than or equal to 12 minimum. The minimum value is 12 millimeter. If it is more than that one, it is well and fine. But they are expecting the minimum thickness of the flange plate. The minimum thickness of the flange plate means definitely I should go for option A, isn't it or not? Devlina, right? Or Aditya Varma, isn't it or not? So this is how you can pick. Is 12 millimeter, right? Right? Isn't it or not? So can I move to the next question or can I move to the next concept? Right? Just moving to the next concept. So before I move to the next concept, I just want to say every day my classes are happening by 11 a.m. So please be aware. And my classes are happening in GATE 2021 Rankers Batch concept through questions. So use that and take use of that opportunity. And I just want to say one more thing. Like I already started a Telegram group. So the name of the Telegram group channel name is Unacademy underscore Civil Engineer Tilak. You can use this channel name. So when you use this when you join this channel name, definitely whatever may be the doubts you are able to post here in this channel. And moreover, when the doubts are in structural engineering background, I personally will respond to your doubts. If it is from non-structured background, the other faculty who are there in the channel will respond to you. Okay, right? And you can join the channel by using this link, Unacademy underscore civil underscore engineer underscore Tilak. By pressing this link, definitely you are able to come down to my channel, right? Yes, right. So okay, let me move to this stiffness. Okay, so okay, right. So stiffness, in stiffness, how many stiffness are there? There are transfer stiffness, or another name for transfer stiffness are stability or vertical stiffness. Why this stability or vertical stiffness are used? A intermediate transverse stiffener increases buckling resistance of the web against shear, right? And angle sections are provided for riveted, or this I already mentioned in the discussions previously. Angle sections are provided for riveted or bolted plate girders, and Whereas flat sections, I can say cross section is a flat or plate section is useful as transverse stiffeners for welded plate girder. I hope you are able to see these are the transverse stiffeners. These are the transverse stiff. No, 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 I will take till 2 p.m. Till 2 p.m. I will take. These are transverse stiffness. And this is nothing but this is the spacing of transverse stiffness, which we people call it as C. What is C called as? C, which is equal to spacing of vertical stiffness, or those vertical stiffness are transverse stiffness, we can call, or spacing of intermediate transverse stiffness. If I provide higher thickness of the web, then the spacing can be more. If I provide very less thickness of the web, then the spacing can be reduced. So like that, you can stop the buckling, and you can increase the buckling resistance of the web against shear action. Right. I hope you are able to see clearly. These are. I hope. Can you see this? Let me show with the help of a color. Red color. What are these? This. This. This, 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 this. I hope clearly you are able to see this. These are vertical stiffness, transverse stiffness. This is the spacing of the plate cutter. I hope you are able to see. This is a railway bridge, and here the span is less. This is the abutment. Here on the side, this is the abutment, and on the side, this is abutment. This is pier one, pier. This is pier. The spacing between these two piers, this is having higher span. This is having, maybe I can say, lower span. Maybe 1 second. Change the color. This is lower span, higher span, lesser span. I can't say lower. Lower maybe you thinking below span. No, it is lesser span, right? So this is nothing but the spacing between the stiffeners. This is the distance between two things. This is nothing but spacing between the stiffeners, spacing between the vertical stiffeners, which we people call it as C. Spacing between the vertical stiffness, which people call it as C. As here it is lesser span, lesser depth is required. Lesser depth. As higher span is there, higher depth of the section is required. You can say, oh, maybe let me change the color. You are able to. Higher depth. Here it is lesser depth for this span. Here higher depth. What is the reason this? Because this is higher span. This is lesser span. I can say lesser span, right? That's the reason why you can understand that, right? Is that okay? So, and one more thing, like, okay, so some people will say, sir, we are using this vertical stiffeners, okay. So to avoid, maybe some people will also ask us, we avoid local buckling of transverse stiffener. So generally, I hope you can say like, uh, show here. Let me show is using this. Add a figure for you. They had already shown, but that using this class. I hope you are able to see. This is, what is this? This is nothing but outstand of the stiffness. So I hope clearly you can say if this is the center line of the web. So from the center line of the web, what is this one? So what is this one? This is nothing but outstand of stiffness, right? So this is clearly I can write outstand. So minimum outstand I need to provide in order to stop buckling of this stiffness. In order to stop buckling of the stiffeners, I need to provide the buckling will happen about this axis clearly. About this axis, the buckling will happen because of this shear action. In order to stop buckling about this longitudinal axis here, there is a minimum outstand is required. So what is the minimum outstand? If I take this is the if I take this is the uh, flange. If I take, for example, if I take this is the flange, for example, this is the flange. On this side, this is in top view. I can say top view. Can I write top? This is flange. On this side, this is a stiffener, vertical stiffener. This is another vertical stiffener. They are vertical stiffener. The this is this vertical stiffener. I hope you are able to see this. This is nothing but outstand. This is nothing but outstand of the stiffener. This is what is outstand of. What is the minimum outstand of the stiffener? 20 times. If the thickness of the stiffener is TQ is the thickness of the stiffener, then the minimum outstand of this stiffener is 20 times of TQ. If the thickness of the stiffener is TQ is the thickness of the stiffener, the minimum outstand of the stiffener, this is outstand. The minimum outstand of the stiffener is 20 times of TQ. In order to avoid, I can say, the maximum outstand. So please understand, maximum outstand, maximum outstand. Maximum outstand of the stiffener is 20 times of TQ. Effective outstand of the stiffener, I can say. Right. You can, if you, some people will say like, sir, I will keep this stiffener outstand maybe 1 kilometer in this way. Maybe on this side also, I will keep the outstand of the stiffener like 1 kilometer on this side. But the effective value of this outstand of the stiffener maybe at max 20 times of thickness of the stiffener only, as per the code of practice, right? That much is only effective in resisting the buckling. Even though it may be 1 kilometer or 2 kilometer outstand, it is useless. So to avoid local buckling of transverse stiffener, outstand from face of the web should not exceed 20 times of TQ. TQ stands for thickness of stiffener. Now the question is, sir, you mentioned here thickness of the stiffener, sir. If this is thickness of the web, I could have found out. Like how I could have found out? So if I had found out the economical depth, the economical depth is cube to root of m into k by fi, sir. If I work out d is cube to root of m into k by fi, I know m. I can fix k. I can fix fi. K maybe if it is 100. I can work out when I work out d. After k is equal to 100, which is equal d by tw, when d is known, I can even find out tq is question mark. This is known. So from this one, I can work out thickness of the web. But you people are saying, sir, you are saying not in terms of thickness of the web, sir. You people are saying in terms of thickness of the stiffener. So generally, what is the thickness of the stiffener? Generally, we can keep coming to the note. Note is generally thickness of the stiffener is equal to thickness of the web. Whatever may be the thickness of the web, that is equal to thickness of the stiffener. So indirectly, if you know the thickness of the web, the same thickness of the stiffener, you can fix it. So based on that one, you can even provide the outstand minimum outstand of the web also using this class, right? Right. Now this is maybe the first class and second class. Some people will say like, sir, okay, sir, you provided vertical stiffener. Now, why this vertical stiffeners you are providing? In order to stop buckling. Okay. So, in order to stop buckling of the web, I can say like minimum moment of inertia with respect to buckling axis. If I am able to increase some minimum more than minimum value, definitely the thing is that shear buckling will be stopped, na sir. Yes, no doubt. So that's the reason why code has advocated or supported, I can say code has advocated or supported, this is the minimum moment of inertia for transverse stiffness or intermediate stiffness. If you had used intermediate stiffness, for example, what is C stands for? So maybe can I rub the screen here? So to teach this second class, the first class is over. Can I start teaching you the second class, bro? Right? Can I rub the screen? Yes, rubbing the screen, bro. Is that okay? Right, right. So class is minimum moment of inertia for transverse stiffener. So if we follow this minimum moment of inertia, generally we follow this class. Okay, generally this shear buckling and crippling of the web will be stopped as moment of inertia with respect to buckling axis for web will be increased if I follow the minimum moment of inertia of transverse stiffener. That is the stuff, right? If I take this is the uh, web, this is in plan. Please consider this is in plan. Okay? In plan, in plan. This is a vertical stiffener. This is a vertical stiffener. This is what is this one is called spacing between the vertical stiffener, which is C, right? And I just want to convey this is outstand of vertical stiffener. This is thickness of the stiffener is TQ. So generally for what I can say, this is the axis about which buckling can happen, right? The axis of buckling, and this is the axis of buckling, axis of ear buckling. Okay. Now for symmetry, generally we had provided this vertical stiffener on one side. Now for symmetry, we'll keep the same vertical stiffener on another side also. Maybe I can say same vertical stiffener on another side. What is the outstand of the vertical stiffener? 20 times of TQ. This is already TQ. This is already maximum is 20 times of TQ. We had taken this 20 times of TQ, right? And this is spacing is C and everything is okay. So now for when the spacing C by D, you know D stands for the depth of the web. Do you know economical depth of the web? How to work out? Is cube to root of m into k by fi. You know C, you know D. You try to fix some value of C. If C by D value is more than root 2, the minimum moment of inertia is this formula, which is 0.75 times of D times of thickness of the web. Maybe I can say is thickness of the web, right? If C by D value, if C by D value generally whatever may be the depth value, the same value of C generally we provide. In such case, C by D is 1, which is C by D is 1. In such case, C by D is less than root 2. If C by D is less than root 2, in such case, minimum moment of inertia for the transverse stiffener. I hope for this hatched portion about this buckling axis, can you work out the minimum momentum? What is the moment of inertia of this hatched portion? Because for the stiffeners, they are expecting the minimum moment of inertia. What is the minimum moment of inertia about this one, which is BDQ by 12. The B is maybe TQ. The minimum moment of inertia IS is equal to base is maybe TQ. Depth is, this is already 20 times of TQ. This is already 20 times of TQ. Maybe I can write it is 40 times of TQ, BDQ by 12 or something like this. You can work out for this hatched portion, which is minimum moment of inertia of this transverse stiffener. This is how you can work out. When this IS value is more than these ones, then definitely you can understand you had satisfied the codal provision that is prescribed by code of practice, that minimum moment of inertia anyway you had provided, right? If you had provided this minimum moment of inertia, in such case the cross section it will be free from, mostly it will be free from web buckling, shear web buckling. That's what I can say, right? Now this is second class, this is first class. Can I talk about third class, which is this one? Coming to third class, the intermediate stiffener is not subjected to any external loading, right? The intermediate stiffener, maybe this is the intermediate stiffener. Maybe can I rub the screen? Erase all. So the intermediate stiffener, which is not subjected to any external loading, should be connected to the web to so as to withstand a shear in kilometer per millimeter of not less than. So maybe if I take, if this is a plate gutter, for example, okay, you had provided so many what we can say, mm, we had provided so many intermediate stiffeners. Maybe this is intermediate stiffener. This is intermediate stiffener. So between intermediate stiffener and the web, you need to design for shear. Between the shear force from the web will be transferred to this stiffener also. So between this vertical stiffener, I hope you can say vertical stiffener and the web, generally I need to provide some minimum for some minimum force. I need to join the weld, I need to use the weld. If I say this is the weld, green is weld, they had used this green weld. Now to design for this weld, what is the minimum force for which I need to design this weld? So the minimum force for which I need to design this weld, when this intermediate stiffener is not subjected to any external loading. When it is not subjected to external loading, in such case, for what minimum shear I need to design the junction. I need to design the connection between this vertical stiffener, and this is the vertical stiffener. Right hand is vertical stiffener, this left hand side is the web. What is the shear force for which I need to design the junction between these two connections, the connection of these two, that minimum shear force for which we need to design the connection in the form of maybe weld, it is thickness of the web square by 5 times of bs. What is this bs? Tw stands for thickness of the web. This is in kilonewton per millimeter. So please understand, this is not directly in kilonewton. It is kilonewton per millimeter. So kilonewton per millimeter in sense strength of the weld per unit length. What is the strength of the weld per unit length? Which is ultimate strength of the weld divided by root 3 into 1 by factor of safety, maybe 1.5 or 1.25 into effective strength of the weld per unit length. So multiplied by effective area. Effective area is throat thickness, which is 0.7 times of size of the weld multiplied by effective length. But I am expecting per unit length. Na? In such case, this is the formula, right? So if you work out this one, that value for that design weld should be more than this one. Should be more than this value. Like that, I need to design the weld. Okay, right. So this is the third class, where BS stands for, where TW stands for, TW is equal to thickness of web, right? BS stands for outstand of stiffener. I already mentioned you previously what is the minimum, what is the maximum outstand of stiffener. So I can say max BS is outstand of stiffener, and the maximum value of outstand of stiffener is 20 times of T cube. So using these clauses, you need to check whether these are satisfying or not. Okay, right. Let me. So first of all, before I go for longitudinal stiffness, I am expecting I am giving a question to you. So can you work out this question, bros? So dear Devalina madam, can you work out this question? Right? This is a question for Devalina madam and Aditya Verma and any other person who are on the online. So can you tell me the answer for this? A welded plate gutter is provided with various stiffeners. If depth of the web plate, which is D, is 2000 millimeter, and thickness of the web, it is 10 millimeter. So in such case, D by TW is 200. Okay. Spacing of vertical stiffness, which is C. C is 1000 millimeter. If I take C by D, C is 1000, D is 2000. C by D, which is equal to 1 by 2, which is less than root 2. I already teach you when C by D is less than root 2, the minimum moment of inertia required for transfer stiffness. What is the minimum moment of inertia required for transfer stiffness? Which is equal to 1.5 times of, I had already clearly mentioned. I hope if you see this class, and C by D is less than root 2, the minimum moment of inertia, IS stands for the minimum moment of inertia of the transfer stiffener. That should be 1.5 times of D cube into TW cube by C square. Right? You need to use this one. So based on this class, I framed that problem. Right? So maybe I can say which is 1.5 times of D cube into TW cube by C square. This should be greater than 1.5 times of depth of the web. The depth of the web is depth of the 2000 cube into thickness of the web 10 cube by C, distance between the transverse stiffness, which is C. C is 1000. I can write. So if you work out this one, this should be greater than or equal to how much? What is the answer? So maybe I can say it is 1200 into 10 to the power of 4 millimeter. Is na millimeter power 4, because it is moment of inertia. It is not section modulus. So millimeter power 4. So I can say you can pick the option C. So that's the reason why these should be memorized, bros. So these clauses, maybe clause 1, clause 2, clause 3. These three clauses values should be memorized, right? So right. So for today, I mean, I am stopping the session for just for today. Before I stop the session, I just want to say like tomorrow we will start the design problem, right? There are few more classes were there. So we will talk about the few more classes, especially on the longitudinal stiffeners, and after that we'll talk about in the tomorrow session like the design of plate gutter procedure. We will talk maybe tomorrow session in sense next upcoming session, maybe tomorrow and day after tomorrow are my offs. Maybe you can expect me on Tuesday. On Tuesday, we will have the same lecture. The continuation of this lecture will be there. In that one, we will see the design procedure of this plate gutters, and we will work out two problem designs of plate gutters. Okay, right. Finally, I just want to convey one thing. Finally, I want to convey we already started two different three different batches. Uh, Three different batches in this Unacademy, in this Let's Crack Gate and ESE Civil YouTube channel. We had already started. So please, if you are a serious aspirant of Gate and ESE or any other thing, I can definitely recommend you these guys. I can definitely recommend you to use these free classes to improve your rank, maybe, or to improve your concepts or whatever that may be. Maybe to improve your reasoning also. Design won't come, but dear Devlina, for objective questions, design won't come. But that design will come for ESC conventional paper. So based on that ESC conventional paper, in the entire design procedure, maybe one or two parts like economical depth of the gutter. So like that, some questions will come, right? So that is for conventional paper. In detail, I am teaching you. Okay, so that practically, if you go to the field, especially the design of that plate gutter is the mandatory. If you want to settle down as a designer, I will teach you the basics. Don't expect me like to teach the 25 hours or 30 hours of plate gutter. I'm teaching as a crisp like 7 hours or 6 hours. I have 7 hours only. I'm teaching on plate gutter. Actually, if I want to teach each and every step of calculation with all the different models, if I want to screw all the clauses in the entire plate gutter, it will take 25 hours for me, only for plate gutter. That's how we will do in case of paid course, and moreover we will do in case of in your undergraduate program also. I use it to teach for 25 hours. Okay, that's how, because this target here is not just for gate, it is also for ESE na. So okay, and I just want to convey like, don't miss this opportunity to learn from India's topmost educators and crack your civil engineering examinations of any kind, maybe descriptive or maybe objective, maybe of gate level, maybe our SSC JE, or maybe our state PSUs. The concept is one and same, brothers. So please take use of this one. And coming to the financial terms, so if you want to take a paid course for 12 months, the after 10% discount, the cost is 27,000 225, I can say. If it is a 24 months course subscription, if you want to take as a paid course, in such case the cost is 39,600. So please, I mean, I can recommend this 24 months course and 18 months course. If you are a student of second year or third year, I can recommend you this one. If you are a student of final year, I can recommend you this 12 months course, right? Okay, and one more thing is, if you want to take the paid course or subscription, don't forget to use this code VT10. When you use this code VT10, it shows your trust on me, and it will direct connect between you and me. I will take care of your entire preparation if you are able to use this code VT10 bros. Okay, don't forget to use this code VT10 bros. Okay, to take the subscription. If you had taken subscription, definitely we are pretty much sure like you are able to get a very good rank base, because of the support from us, because of lecture support, because of doubt clarification support, because of test series support, because of lecture support, online lecture support, and because of maybe you can watch the same thing for n number of times, offline support also. So all these supports you are able to get when you had taken the paid course, which is not there for free users, bros. So you can understand that. Okay, and you can follow me by using this link. I hope you can click this link, press this link. You are able to directly follow me by pressing this link. When you are able to follow, whatever maybe the free content that I had already delivered in Unacademy learning app for free of cost, that you are able to access again and again for so many number of times. That is first advantage. Some free content, some free notes that I had already kept for you, that also you are able to access. These are in addition to that one, the future coming videos in Unacademy learning app will also be notified to you if you are able to follow me, right? So every day my class is happening by every day my class especially is happening by 11 a.m. Every day my class in structural engineering is happening. I will teach all the structures. So every day my class is happening by 11 a.m. So you can follow me every day by 11 a.m. Tomorrow and day after tomorrow are my offs. Maybe you can not, maybe you can see the next coming second part of plate gutter on Tuesday. Okay, right. And don't forget to use this code VD10 if you want to take the subscription, bros. Dear bros, I just want to say one thing. If you are really wanted to crack good rank with Gate, in such case subscription is a mandatory. Subscription will give you a lot of support to you. When you had taken a lot of support, and when you follow stick to that when you stick to that structured course, definitely we are pretty much sure like you are able to get a good rank. There is no doubt at all. And I can say one more time, I had already started a Telegram group for you, and the name of the Telegram channel is Unacademy underscore civil engineer Tilak. If you don't if you want to directly join to this Telegram group, you can use this link which is given below. when you use this, when you press down this link which is given below, right, definitely I can say like it will redirect to my channel, and you can join my channel. And don't forget to press the bell icon, bros. And let's crack, please subscribe to our YouTube channel, Let's Crack Gate and ESC Civil YouTube channel. So the future coming videos will also be notified to you, brother. And stay tuned to our channel so that you will get more free content, definitely for sure. And you will get more number of faculty are going to teach. So please stay tuned to our channel. And I can say don't forget to press the bell icon. Use this code VT10 to get subscription, brother. If you want to take the subscription, use this code VT10. And don't forget to subscribe to our YouTube channel. And please raise a thumbs up for our video, for my videos, especially so that I can do more free content for you, so that I can do more attractive sessions for you. Thank you very much, and thank you. End of this session, bros. Thank you very much. Please, I had a small request. Please share the same videos to your friends so that they will also get benefit. At least for free of cost, at least they can learn something now. So why can't you share these videos to your friends? So thank you.